The length of a line. If we have 2 points, x and y, um, p, x1, y1, q, x2, y2. Let us draw a dashed line like this. What would be this? Where would this dashed line meet the x-axis? It would meet it here at x1. Let us draw a dashed line from Q till it comes down and meets the x-axis. This point here would be x2. Let's do the same over here. What would be this value here on the y-axis? This is going to be y1. I will extend this dashed green line here till it meets this other line. How about here now? What would be this value here? Well, this would be y2. We are interested in the length of this side and the length of this side of this triangle that we're seeing. Now this triangle is a right angle triangle. The distance between y2 and y1 from here to here is simply the larger number, which is y2, subtract the smaller number, y1. And that will give us this distance here, which just so happens to be the length of this side of the triangle, y2 subtract y1. What is the distance between x1 and x2? Well, this would be x2 subtract x1. Therefore, the length of this side of our triangle is also x2 minus x1. We have a right angle triangle. Let me give this point a name, this vertex here. I will call it R. So, if we were to use Pythagoras' theorem, to find the length of the side PQ, what we would have? We would have PQ squared is equal to PR squared plus QR. PQ is equal to the square root of PR squared plus QR squared. So we have PQ is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. This here is a formula to calculate the length of a line or the distance between 2 points. Let's do an example. Example 1. Find the length of the line AB if A has coordinates -7, 3, and B has coordinates -4, 7. Solution. The first thing that we will do whenever we're doing a problem like this is label our coordinates. Let me write that here. Label, use a different color. Label coordinates. Very first thing. So we call this one x1, y1, and here x2, y2. It does not matter if you had labeled here x2, y2, and here x1, y1. You would get the same result. Now, AB, we write the formula. AB is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. This is equal to the square root of -4 subtract -7 squared plus y2, which is 7, subtract y1, which is 3 squared. So we have here -4 plus 7 squared plus 4 squared. So this is equal to the square root of 3 squared plus 4 squared, which is square root of 9 plus 16, which is square root of 25, and this is equal to 5. Because we do not know, the problem does not tell us whether the coordinates were measured in centimeters, millimeters, kilometers. It does not say. We simply acknowledge the fact and write units, whatever the units mean. Let us do another example. Example 2. Given that M is the point, -3, -1, and N is the point, 5. Find the distance between M and N. Solution. So we have the points given. M is the point, -3, -1, and N is the point, 5, 5. The very first thing that we do, we label our coordinates. x1, y1, x2, y2. Mn, which will give us the distance or the length of the line Mn, this is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. So this is equal to 5 subtract -3 squared plus y2, which is 5, subtract y1, which is -1. So what we have here, this is the square root of 5 plus 3, that's 8, 8 squared, 5 plus 1, which is 6, 6 squared. So this is the square root of 64 plus 36. So the square root of 100, which is equal to 10, guess what? Units. Now go ahead and do the exercise.